Okay, guys, so let's start. So today we are going to finish 3.5. We already did 3.4 about spanning. Can you hear me well, guys? So what we have seen before, it was about spanning. Assume we have, please guys, click on yes for present. So what we have seen before, it was about spanning. Let's say we want to see if V1, V2, V3, three vectors spanning vector V, or V1, V2, Vn spanning vector V. So we were doing A1, V1 plus A2, V2 plus An, Vn equal V, right? If we have V, it's fine. If we don't have it, we write A, B, C, D, or X1, X2, X3 as you want. For spanning, so this one is for the section 3.4. So for spanning, we have this system. We write the augmented matrix. For the augmented matrix, we have two cases, either consistent or inconsistent. If it's consistent, means V1, V2, Vn. What it's black. Can you see the lecture, guys? Yes, Fatma, please reconnect, Fatma. So V1, V2, Vn spans V. If it's inconsistent, means V1, V2, Vn does not, very good, does not span. Very good. So this one was for 3.4. Now for 3.5, look what we will do. 0.5, it's very easy. It's same idea, but look, instead of V, we will remove Z, we will put 0. We will put vector 0, means here we have homogeneous system. What do we know about homogeneous system? It's always what? It's always what? Oh, yeah, I know. No, false. It can be trivial, it can be infinity many solution. It's always consistent. Always. So here, always consistent. So it's different than span. It's always consistent. So we have two cases. We have either trivial solution, unique trivial solution. What does mean unique trivial solution? Means they are all equal 0. In this case, we say it's V1, V1, V2. Vn is linearly independent. In the vector space V. Now, if we have, what's the second case? Infinitely many solutions. So in this case, what's the opposite of independent? We say V1, V2, Vn is linearly what? Dependent in V. That's it. This section is only about this one. So you write the system, homogeneous system. You write those. You take the augmented matrix. You solve, and if you have unique solution means independent. Infinitely many solutions means dependent. Is it clear? So this is what we will do in this section. Is it clear, guys? So please take screenshot what we will do for the rest of the exercises. So just now we will do exercises, we apply this definition, and that's it. Very easy. Please, all of you, take screenshot, keep it. How to prove that set of vectors is linearly dependent or independent. So independent means we have unique trivial solution. Dependent means we have infinitely many solutions. How we will do it? We will do it using REF, as we did for span. Yes, for sure. Always REF or RIF, you will get the same result for sure. But RREF, it takes more time. Okay, let's start this exercise. So here we have how many vectors? We have 3 vectors, and we want to see if they are linearly dependent or independent. So let's write the definition. So we write A1v1 plus A2v2 plus A3v3 equals 0. Now, what's the augmented matrix? 3, 2, 1, 1, 2, 0, -1, 2, -1, and here all 0. Isn't it? Okay, Romana, don't worry. Now, look, we have one leading one, but on the wrong location, so we interchange R1 and R3. So we get 1, 0, -1, 0, 2, 2, 2, 0, 3, 1, -1, and 0. So now we have leading one. We have to cancel everything below 1, below the leading one. So R2 minus 2 R1, very good. R3 minus 3 R1. 1, 0, minus 1, 0, 0, 2. Here we get 2 plus 2, 4, 0. Here for sure 0. It will remain 0. If you have homogeneous, you start with zeros, it will remain always 0. And just a second. And here, what do we have? We have 0, 1, 2, 0. Now, guys, either we divide by 2 or we interchange. What do you want? The first one will answer. I will take it. Take his answer. Okay, we divide. What's this to? I don't understand. You mean you divide by 2, Abdullah? Okay. Sorry, Nora, because he answered before you. It wasn't a full answer, but anyway. 0 minus 1. 0, 0, 1, 2, 0, 0, 1, 2, 0. Now I'll take R3 minus R2. So we get 1, 0, minus 1, 0, 0, 1, 2, 0, 0, 0, 0, and 0. So don't forget what are the variables. The variables are A1, A2, A3. So here we have A1, A2, A3. Let's see the leading ones. For every canon row, we have to search the leading one. Here, this is the first leading, the second leading, and for this row we don't have. So look, A3 does not have leading one. So how many solutions do we have? Hello guys, how many solutions? Infinitely. So the system, so the vectors conclusion, linearly dependent or independent? Is a linearly very good dependent set in, we are in which vector space? What's the vector space here, guys? R3. Very good. That's it. So you see, very easy. Please take screenshot of how to solve it. Yes, if you want, a little bit similar. 3.4, we care only about consistent or inconsistent. Here, we care about solution. Is it unique or infinitely? Okay. So here are the polynomials. So you see example 6, page 191. We have polynomials P1, P2, P3. We want to see if they are linearly dependent or independent. Here, what is the vector space here? Very good, P2. Very good. Not P, P2. Because they are all degree maximum 2. So let's we write the definition. Always you need to write the definition. A1 P1 of t plus A2 P2 of t, A3 P3 of t equal to 0. And for polynomials, I taught you how directly to write the augmented matrix. So t squared, because it's P2, t and 1. Yeah, guys, for P1 of t, what are the numbers? 1, 1, 2. Very good. 1t squared, 1t, and number 2. For P2, 210. Very good. And for P3, 322. And for 0, we don't have. We have 0t squared, 0t, and 0 number. So now we do R2 minus R1 since we have leading 1. R3 minus 2 R1. Just a second. We'll open the window. So we get the same. First row is the same. 1, 2, 3, 0. Now minus 1 plus 1. Minus 1. Minus 1, 0. 0. Minus 2. Minus 6 plus 2. Minus 4. And 0. Now we divide R2 by minus 1. 1, 2, 3, 0. 0, 1, 1, 0. 0, minus 2, minus 4, 0. I have the second leading. So R3 plus 2 R2, correct? Very good, Nora. So we get, you see, section. This one is from chapter 2. You see, REF, what I taught you in the beginning was very important, always, very important. Now here, 1, 2, 3, 0. 0, 1, 1, and all zeros. Again here, let's check what do we have. So we have A1, A2, A3 as variables. Leading, the first leading is here, the second leading here, and we don't have third leading. So A3 does not have leading 1. So we have infinitely where minus 2. Ah, here, here, minus 3 plus 2 minus 1. Ah, here. Just again, 1, 1, 2, 2, 1, 0, 3, 2, 2. So R2 minus R1 minus 1 minus. Here it's minus 4 here. Okay, now, just a second. I verified the calculation. Everything is fine now. You verify it, guys? Okay. So we have infinitely many solutions, correct? Very good. So we have infinitely many solutions. In this case, what's the conclusion? The set is linearly dependent or independent? Very good. It's linearly too simply. So the set, or let's this time write the polynomials. P1 of t, P2 of t, and P3 of t are linearly dependent because we have infinitely many solutions. Please take screenshot. A3? Yes, for sure. Because we have three polynomials, you need A1, A2, A3. Okay, Nora? Very good. So now we have exercise 2, page 196 from the textbook. Shows that the set V1, V2, V3, we have V1, V2, V3, is linearly independent in R3. Let's see if it's linearly dependent or independent. They said it's linearly independent in the textbook. So we write the definition. Always, guys, you start with definition. A1, V1 plus A2, V2 plus A3, V3 equals 0. And here we write the augmented matrix 1, 2, 1, 0, 1, 1, 2, 0, 1, and here zeros. Correct? Now we have leading 1, so we take R2 minus 2R1. Please follow my calculation. We don't want any mistake. 1, 0, 2, 0, minus 2 plus 2, 1, minus 4, 0, and 0, 1, minus 1, right? 0. Now I have second leading. Here we make R3 minus R2. 1, 0, 2, 0, 0, 1, negative 4, 0, 0, 0, 3, 0. Very good. And R3 divided by 3, we get 1, 0, 2, 0, 0, 1, negative 4, 0, 0, 0, 1. Very good, Nora. So here we have A1, A2, A3. Leading first row, we have leading. Second row, we have leading. Third row, we have leading. So we have how many solutions? We have the unique trivial solution. Very good. The unique. Why it's trivial? Because here it's homogeneous. Unique trivial solution, which is A1 equal A2 equal A3 equal 0. Conclusion, it's independent. Very good. So we answer the question. Show it's linearly independent. V1, V2, Vn, V3. is linearly independent because we have unique solution, so it's independent in R3. Here, the vector space is R3. Too simply. Understood, guys? Very good. If you want take screenshot, guys. No, R3. R3, P1, P2, R2. So you are responsible of R2, R3, P1, P2, and for example, matrices M22. Look here. What is this here? In which vector space? We have R the vectors. So you see, sometimes we call them vectors or polynomials, no problems, because we are talking about vector space. But just you have to know that this one is not normal vector, it's a polynomial. So here we are in which vector space, guys? Very good. So let's write definition. A1 V1 plus A2 V2 plus A3 V3 equals 0. We write the augmented matrix. Don't forget here we are in P2, means we have to put coefficient t squared, t and 1. So V1 is 210, very good. V2 103, very good. And V3 t squared we don't have, t we have, and number. And for 0 is 0 t squared, 0 t and 0 number. Now we interchange R1 and R2. Right, Abdullah? 101 0 2 1 0 0 0 3 0 0. Now R2 minus to R1, as we said. 1 0 1 0 0 1 minus 2 0 0 3 0 0. I have leading 1, so here R3 minus 3 R2. 1 0 1 0 0 1 minus 2 0 0 0 R6. Okay, 0. I didn't look on it. Now R3 divided by 6 to get, is it linearly dependent or independent? Very good, independent. Why? Because we have leading 1, leading 1, leading 1, A1, A2, A3. We have the trivial solution. A1, A2, A3 equals 0. So linearly independent, where in very good. Nura, look here, they are all in P2. If you want, you can take screenshot. Okay. So, guys, now look, we have one important fact. It's very, very important, and it's applied only for vectors, for Rn, not for any space, not for vector space, not for matrices. So please follow me. Look here what we have. So we have important fact only for Rn, for B equal Rn only. If you apply it for vector space Pn or matrices, I will put 0. Okay, you have to apply it only for Rn. So, look, guys, it says if we have how many vectors here? V1 to Vk, how many vectors? K vectors. Not many, K. From 1 to K, it's K. Like from 1 to 10, we have 10. Okay? Otherwise, guys, if you want to count, can you know from 3 to 26, how many numbers do you have? Who knows? We have, no, how many integers? I mean, 3, 4, 5, 6. How many numbers? Not how many real numbers. How many natural number? We have 24. Because you have to count 3 also. 3 is one number. 3, 4, 5, 6. Okay? So from 1 to 10, you have how much? 10. Look how to know. Always, if you want to count from m to n, you do n minus m plus 1. For example, from 1 to 10, 10 minus 1, 9, plus 1, 10. From 2 to 10, basically it must be 9. So look, count. 10 minus 2, 8 plus 1, 9. Okay? From 3 to 26, count. 26 minus 3, 23 plus 3, plus 1, 24. Okay, guys? For example, from 0 to 10, how many numbers? From 0 to 10, it's 10 minus 0. 10 plus 1, 11, because you will count 0. So, here we have k vectors in Rn. So we have two numbers. We have k and n. N is the power, k number of vectors. Fine? So, look, always, guys, if you have number of vectors is bigger, strictly bigger than n, directly the set is linearly independent. Directly you can say it. You can say directly it's dependent. No need to prove it, okay? Directly you can apply it. Clear? Now, if k equal n, then look what you can do. Directly you can find determinant of v1, v2, vk, or vn, because k is equal to n. If you have two cases, determinant. If it's equal to 0 means, if A is singular, this matrix here singular, means we have v1, v2, vn linearly dependent. If it's different than 0, then we get V1, V2, Vn linearly independent. Is it clear? So if k equal n, you can directly find if they are linearly dependent or dependent using determinant. And this one is only for Rn. And when k is equal to n, not anything else. Now, for the last one, if k is less than n, then you don't have the choice. You have to apply the definition. You write a1 v1 plus a2 v2 plus ak vk equals 0. If you get unique solution, means it's fine. Means means linearly independent. If you have infinitely many solutions, means dependent. Clear? Very good. Let's see some examples. Look here. Determine whether the set v1, v2, v3 is linearly independent in R3. Here, k is equal how much? Number of vectors? 3. N, here it's where, what's the vector space? It's R3, means n equal to 3. So you see k equal n. So we can apply determinant. Let's find determinant of v1, v2, v3. Here means column, column, column. Means determinant v1, 1, 2, 3, 0, minus 1, 2, 0, 0, 1. What's the determinant of this matrix, guys? Very good. Why minus 1? Because this one is triangular, so it will be 1 multiply negative 1 multiply 1. So we get minus 1 different than 0. So v1, v2, v3, is it linearly dependent or independent? Independent. So you see, look, it takes 5 seconds. In R3 here. Too simply. Any question, guys? Why we were able to use determinant? Because k equal n. So you have to show, if you want to use determinant, you have to show this one. Okay? For that here, n equals 3, it's only for vectors, not for polynomials. So you can apply it only for Rn. Do we move? We continue? Okay. Here, we have also vectors. K equal how much? Number of vectors. 4. N, look, is strictly bigger than 3. So we are in which case? We are in case 1. So what do we get? We get directly, it's linearly dependent. Very good. So it's linearly dependent. So the set v1, v2, v3, v4 is linearly dependent. Too simply, you see? No calculation. We didn't do any calculation. Difficult? Very good. Khalifa, everything is fine? Very good. we want to find x so that the vectors v1, v2 are linearly dependent in R2. Okay, because we have linear dependent, let's directly think about determinant because it's easy. Okay, k is equal to how much? Number of vectors? 2. And n also 2. So k equal n. So we can use determinant. What does mean they are linearly dependent? Determinant equal to 0 or different than 0? Equal or different? Very good. Equal to 0 since because v1 and v2 are linearly dependent. Now, let's solve. v1 is 2 minus 3, 1x. We substitute equal to 0. So from the right, we have 0. From the left, what's the determinant of this matrix? No. Yes. It's 2x plus 3 here. So we move 3 to the other side. So 2x equal minus 3. And finally, we get x equal minus 3 over 2. So for which value of x we have linearly dependent, it's x equal minus 3 over 2. Otherwise, it will be independent. Clear, guys? So now we will go back to the previous exercises. We did them with REF. Let's see if we can do also with determinant and to verify that everything is fine. Here it's dependent. It's already dependent. The question is to find x so that the vectors are dependent. Okay, Hamad? Okay. So let's go back. One we solve it. This one, can we do determinant here? Yes. So let's check. Here we have k equals 3, n equals 3. So we have k equal n. Let's find determinant v1, v2, v3. So we want to see here if they are linearly dependent. They are linearly independent. Let's check. We must get something different than 0. So it will be 1 to 1, 0, 1, 1, 2, 0, 1. So to solve, let's take which row or which column? Let's take the first row. For the first row, we have plus minus plus. Right? The cofactor. So 1, we don't change the sign of 1. 0, we don't care. And 2, we don't change the sign of 2. So hide 1, hide row and column containing 1, we get 1, 0, 1, 1. Hide 2, we get 2, 1, 1, 1. So what do we get here? 1 minus 0, here 0, I don't care, plus 2, 2 minus 1. So we get 1 plus 2 equal to 3. Difference than 0. So which one, Nora? I'm doing the determinant. This one is chapter 6. Determinant. Here, when you take first row, A11, capital A11, plus A12, capital A12, plus A13. So here, A11, capital A11, A12, No, here just I'm applying because k equal n. You can use determinant to see if they are linearly dependent. Look here, you get different than 0, so v1, v2, v3. This is the second method, is linearly independent. This is what we get before, and now we are doing the same in R3. So you see? So sometimes with determinant also it's very fast if you don't want to do REF. So you can do REF or determinant as you wish. Clear, Hamad? Nora, everything's fine? Here, can we use determinant, guys? Here, no. Why? Because we don't have Rn. Pay attention. Here, can we use determinant? Yes. Let's check. Look, we get linearly dependent. Let's check if we get the same. Let's check if we will get linearly dependent. So we have, by the way, this is the last one, guys. And then we are done. We have k equal 3. And so here, what is the vector space here? R3. So n equal to 3. K equal n. Very good. So let's see the determinant of v1, v2, v3. It's equal to 3, 2, 1, 1, 2, 0, negative 1, 2. Minus 1. Here, let's do the last one. So the last one, remember, we have plus, minus, plus, minus, plus, minus. This is the last row. So for the last row, A31, A32, A33. A31 is positive, so we don't change the sign of 1. And in this case, we hide row and column containing 1, so we get 1, minus 1, 2, 2. 0, we change the sign of 0, but we don't care about 0 because 0 multiply everything is 0. Minus 1, look, you see, we don't change the sign of minus 1. Plus means we don't change the sign. Minus. So we don't change the sign of 1, we don't change the sign of minus 1. So here, and but for 0, plus, minus 0 is the same. I don't care about 0. 3, 1, 2, 2. Very good. So we get 2 plus 2 minus 3 multiplied 2 is 6 minus 2. So we get 4 minus 4, 0. You see? So v1, v2, v3 is linearly dependent in. Pay attention, guys. If you use determinant for polynomials, I will consider it as false. We do it only for Rn. Because it has 0, Nora. It seems you forget determinant. Remember? Or second column, yes. Second column also has 0. Very good. Everything's fine, guys. We are done for today. Please, your questions are welcome. Don't forget, next week we have assessment. It will be online, submission online. If you don't submit before the deadline, you can change many times. But once you submit, pay attention. You can only have 2 attempts, only 2 attempts. So please be careful. You have true, false, multiple choice, and 2 workout problems. You will see it on Wednesday, as usually, Wednesday, 8 p.m. and submission Tuesday after 5 days, without counting Friday. No, it will not change. Thank you, Dina. Thank you, everyone. Have a nice weekend for all of you. Thank you, guys. Please stay safe and uh, take care of yourself. No, next week we have only assessment. No, Noura. As for ICA, once you click on your solution, it will be saved. Okay, as you did for ICA. Don't worry, and you have 6 days if you count Friday. If you don't count Friday, you have 5 days. So you have time. Don't worry. You have 2 attempts. Even if you do mistakes for the first attempt, you can change for the second. So basically, don't submit until Tuesday. Tuesday, when you make sure everything is fine, then you submit. Thank you very much, guys. Thank you. Have a nice one.